Okay, here is week two. We're going to continue looking at some pre-calc concepts here again. And the whole idea here, remember, calculus is analyzing functions. Okay, so what we're doing is establishing, the basic elementary functions, and then, when we move on in the course, we'll begin to analyze those functions. But right now, we're laying the foundations of the things that we are going to be analyzing. You will run into polynomial functions a lot, and polynomial functions are something you've worked with quite a bit. As a matter of fact, even starting in Algebra 1, when you work with lines, a line is a polynomial function because it fits this definition where we have, either y equals, or in this case, f of x equals. But the key here is that the coefficients of the independent variable x here are real numbers. Usually you're given either fractions or, integers. So you'll be dealing with rational numbers. Theoretically, we could have a square root of 2 or square root of 5 or pi or something like that that's an irrational number be a coefficient, but that's very rare dealing, especially in this course. The other thing is that these exponents have to be integers. Okay, so that means we have, here like the n would be 3, and normally we write these in descending order. So if that was the third power, the next term would be the second. Sometimes we skip powers too, and the next term would be the first power. And then actually a constant term technically fits into this, right? Because if this is, you know, the first coefficient to the first power, then a to the 0, or a sub 0 times x to the 0 would just be 1. So a constant term is really multiplied by x to the 0 power. Some of the characteristics, and this is what we're going to focus on because sometimes it's good to know what the graph should look like before you graph it. That if you have an nth degree polynomial, that would be the highest power, okay, of that polynomial. We got some examples down here. There's going to be n minus 1 turning points. So if you have a fourth degree, that's the highest power for, then you have at most 3 turning points. Now you can have less than 3, but you have at most 3 turning points. And if it was a fifth, then you have at most 4. Here's just the converse, or they're stating the converse of it. If you know you have 3 turning points, then you know it has to have a degree of at least one more than that. Okay, you just add one, and that's just the converse of what we're saying here. The basic shape here, if it's an even degree, both ends go up or both ends go down, and then if it's an odd degree, one goes up and one goes down. So if I have like a fourth degree, a sixth degree, a 10th degree, those are even numbers. And the same thing down here with the odds. It's going to look different, right? It goes up on one end and down on the other. As we go to the positive direction, if the graph goes upwards, then that means that the leading coefficient or the coefficient of the highest term must be positive. So let's take a look at some examples here. Here again, we're saying that the leading coefficient is positive in all these graphs. We didn't give their equations, but here's degree 0. Just think about it. A 0 degree function is just a constant function like f of x equals 5 or f of x equals 3, or so it's just some constant value. A first degree, like 2x plus 4 or something like that, then it's going to look like this. Remember, that's an odd number, so it's going to go up in one direction and down in the other. And then it gets a little more interesting, right? Because, first degree has 0 turning points, right? Okay. And then now we have a second degree, there's our 1 turning point, okay? Here's a third degree, there's our 2 turning points right here. A fourth degree, there's 1, 2, 3 turning points. Here's a fifth degree, 1, 2, 3, 4 turning points, okay? Now, keep in mind, this could also be a seventh degree one, okay? Because it just has at most one less than that, okay? So a seventh degree can have 4 turning points, just as a fifth, but it could be a seventh or a ninth or an 11th, if for that matter, okay? Same thing over here. These 3 turning points, this is a fourth degree one, but it also could be a 6th degree or an eighth degree, okay? Because remember that phrase, at most. If we get down here into, a couple more examples here. Now, if I look at the graph, I sit there, 1, 2, 3 turning points, okay? Since it's going up on both ends, I know the leading coefficient is 1, okay, or positive leading coefficient, I should say. It's positive, not 1, but positive. And it has to be at least a fourth degree, okay? Because again, I have 1, 2, 3. So it has to be at least fourth, but it could be 6, 8, or 10. And the same thing or similar thing over here. Now, this one here, okay, since it's going down to the right, remember, if it's going up to the right, it has a positive leading coefficient. This one's going down, so it has to be negative. And then we have 1, 2, 3, 4 turning points. So it has to be at least a fifth degree, but it could be higher. Okay. Here's just some problems that would be in your set. Now, just to show you, you can get around this with a grapher, and I have Desmos up here and running, but you could just do this quickly with the process of elimination here. And that is, okay, a fourth degree is going to go up on both ends or down on both ends. Since the leading coefficient is negative, I know it has to go down on both ends. Well, the only graph that satisfies that particular characteristics is option C, okay? This could be a fourth degree, right? Because I have 1, 2, 3 turning points. Okay, it could be a fourth degree, but that negative throws this one out because it has to go down on both ends. This one here, okay, it doesn't, it's going up on both ends. So this could possibly be a fourth degree also. However, because it's going up, it's thrown out for the same reason as this. This is clearly an odd degree, so we wouldn't even consider that. So that only leaves us with C, okay? Again, same thing here, similar type of problem. Now, I might as well do this. So what is that? Negative x to the fourth plus 2x cubed. So I'll just use the f of x notation. Negative x raised to the fourth power. And I could just be using this thing here, the keypad, plus 2x cubed. See how good my memory is, how quickly I forget. Okay, and this is the button for the exponent here, and that'll allow me to type that in. Then you just have to click down here when you type that in. Let me see if I can remember these last two. Plus 11x plus 17. All right. If I quit talking, I'll be able to remember. Okay, now, if I graph that, and this is the standard window, okay, I look at it and it's like, oh, that's not any of these, okay, if I look at it. So this one is clearly the only option. I guess this one looks like it more than the others, but you would have to do some zooming around here. And you could see that if I played around with this window a little bit more, I could get that graph to look a little bit more like what we see here. But you're probably going to spend enough time fussing over here with this that you could just quickly do the problem by applying the concepts that we've talked to here or talked about, okay? For instance, if I came over here and let's say I just changed my min and max to go, from like -5 to 10, it's going to look a lot more like the graph that we have on that screen there. Well, I must have hit -50 here. Let me try that again. -5. Okay. See, and now again, it helps to know a little bit about what the graph should look like, but that one looks a whole heck of a lot like that one. And like I said, by the time you get done fussing around trying to match up your Desmos graph with the graphs that are available here, you'd be better off just applying the principles that we discussed. Okay, so that's one type of problem you'll get here for polynomials. This again is a lot like the other ones here. They just kind of word the question a little bit. Now you're given a graph and they ask you about the degree. Okay, so the key here is I have 2 turning points. All right, so I know it has to be 3 or higher. So I guess I have to pick the best option out of these. And obviously 4, that throws that out because it's an odd one and it has to be, again, 3 or higher. This one's out because it includes 4. So my only option there would be A. Okay. And similarly, like this, for this particular one here, um, notice, I think the reason I did, you know what, I didn't expose the other, there's a second part of this. So if I gave it positive or negative, this should be a positive one for the leading term, okay? That's how they're expressing the highest power here, the leading term. So it has to be positive because it's going up to the right. And that would be the second part of this question. You would push the plus sign there. So this is just a PDF document here of an example. So I'm just showing you here. And then obviously you would pick this option first. Once you select this, then the second one will pop up. Okay. So for this particular one here, for number 4, I count 1, 2, 3, 4 turning points. So this one must be 5 or higher. Okay. So out of these answers here, again, B would be the best one because, again, anything that would be even would be incorrect. So the only option here would be B. Again, 1, 2, 3, 4 turning points. So it has to be degree 5 or higher. Okay. So I think that takes us down to net rational functions, and I'll come back and maybe make another video for rational functions. All right. We'll see you then.